Hello everyone. I want this to be interactive, so if you have questions, please stop me. Since I didn't know the audience for this, I kind of just went at the 50,000 foot overview of what we do and why we use Panasas. You will notice that I'm going to be walking back and forth a lot, mostly because I was told that this is being recorded and it's going to make it really difficult for the cameraman to follow me back and forth. So I got to get some enjoyment while I'm up here. So for the presentation, I'm going to talk about who TGS is, what's our challenges, and why are we on Panasas. So TGS is a multi-client seismic company. We go out and acquire on-spec data all around the world to sell to the oil and gas industry. The oil and gas industry uses our data to do their prospecting, to do their exploration, to get all the underlying information they need before they go drill a hole. As you can see here, we've got about 750 employees, which is kind of nice because my team is small, so I don't have to deal with procurement. I don't have to deal with all the bureaucracy that a lot of y'all do. So the decision lies in these three people that are sitting right here. It makes it really, really easy. The obligatory slide with all our products. Most of it, I'm sure, means little to nothing to most of y'all, but the short and sweet thing here is we go out and acquire a lot of data. This is our worldwide data coverage map, and you can see that we go out and acquire data all over the world, both onshore and offshore, and our bread and butter is the offshore seismic business, and I'll talk about that here in a little bit. So what are our challenges? These challenges to the people that are already doing HPC and that are already using Panasas probably look pretty familiar. For those of y'all who are looking for high-speed storage, this is going to be your world. Our challenges really come down to these four things. One, we're being asked to shorten our delivery timelines, and I'll talk about that in a second, why the timelines matter to the business and why they matter to us as the HPC group. The other thing we'll talk about is the sharp increase in our compute needs. Today we run an on-prem data center that's roughly about 40 petaflops. If the business had its way, it'd be closer to 120. But it doesn't make sense to scale up to that size, so we're trying to get them to manage their expectations. We're dealing with larger and larger data sets, and they're getting more and more complex. And I'll talk about that again in a little bit. And then last but not least, I'd say about 24 months ago, we started down the ML and AI path, and that has completely changed the workload on our HPC. So now we have to deal with how does that impact our storage, how does that impact our HPC, and all the pieces that come in behind it. So really quickly, when we go out to acquire a marine seismic survey, you can see it takes us a little bit of time. We spend 6 to 18 months in the project development phase, and probably another 3 to 24 months going out and doing the actual acquisition, and then another 3 to 24 months on compute. So it could be 5+ years from idea to actually getting a product that is sellable and making money on the shelf. So with this timeline, you can see why the business wants to shorten this timeline. And well, there's a lot of ways you can do it. And then here, what I'm going to splat out for you is a acquisition project that we have slated for the beginning of 2020. It's a really short acquisition, should only take us about 3 months to acquire. But as you can see from the timeline, it's going to take us 9 months or more to process it. And when you're looking at these jobs, they're about half compute, half people intensive. So the processors will sit there and they'll work out all the algorithms and what the flow should look like, and then they submit it to the HPC to do work. When they get it back, they're like, oh no, this is wrong. They'll submit it again. And it's a very iterative process. So when we're looking to reduce the overall cycle time, we can either reduce the amount of time that people use during their piece, or we can reduce the compute time. Okay, well, it's easier to reduce compute time than change people's processes and workflows. So let's start there. So how do we do that? Well, we could throw a lot more HPC gear at it. Or we could try to find efficiencies elsewhere, and I'll talk about that here in a second. Oops. So what you have there is an actual chart of what our workload looks like for 2020. And I drew the line where our compute resources sit today. As you can see, we have quite a few spikes that go well over that compute resource. And the only way to handle all of that would be to either push projects back, so delay when they start getting worked on, or come up with some creative solution of getting through them. If we were just going to use the compute facilities as they stand today, it would take us 31 weeks into 2021 to complete this workload. So the important thing here for us to note is that we can't build for these spikes. So we have to start looking for efficiencies elsewhere, and that's going to come from the network, from our storage, from how we push the I/O from the storage to the HPC, so on and so forth. So our storage vendor must be able to help us do that. They also must be able to deal with thousands of nodes trying to access the same file at the same time. When these jobs kick off, our data is not a whole bunch of small files. It is a few very, very large files that each node has to read a small bit of as it gets started with its compute. So it's really onerous, and I think we've tested to date 25 probably plus storage vendors, and only 2 have held up under full load. So our storage has got to be able to handle that. It's got to be able to handle the data access patterns. It's got to be able to scale linearly. And last but not least, as Steve mentioned, it's got to be simple to support. We're a small team. I don't have a whole bunch of resources to throw at the problem. I have one guy. So, yeah, that one. So it's got to be easy. It's got to be reliable, and not take up too much of his time, because I know there's other things he'd like to be doing. Yeah.
On the prior slide, what's driving the big spikes?
Just the increase in projects that we're undertaking and the increase in their complexity. And this is actually a great segue. Thank you. The newer surveys are much more dense, a lot more recordings are happening. So back when TGS started, a seismic vessel would go out with one streamer, and it would probably be 2 to 3 kilometers long, and it would have maybe 500 receivers on it. Modern vessels carry 16 streamers that are spaced maybe 150 meters apart, so that spread right there is about 1.5 kilometers wide, and the streamers are now 8 to 10 kilometers long. So each one of those streamers is collecting a lot more data. And you can see with the graph in the top right there that back when TGS started, each shot was roughly about a megabyte a shot. Now when we're talking today, we're upwards of 30 gigs a shot. So the data is just getting denser, more complex. Today we have surveys coming in raw before we get started with them at somewhere between 3.5 and 5 petabytes. Today we're currently spending roughly about 23 petabytes of Panasas, is that right? Yeah. All right, 23 petabytes. I expect by the end of 2021 we'll be closer to about 100, 150, just because of the change in the nature of our workloads. So from here, yeah, if we're going to choose a storage vendor, they have to be able to work with us to optimize our storage access patterns. And I think Nick is on the phone with his support reps on a regular basis. We have to have the top-notch support, and that last bullet is not so intuitive, but they have to be able to deliver the storage when they say they're going to deliver the storage. I cannot tell you how many times we go to market, bid something, buy it, and get told that it's going to arrive in 12 weeks or 15 weeks, and that timeline goes right by, and we're at 20 and 25 weeks, and we're losing money. So that last bullet is actually quite important to us. Oops. Very touchy. Last but not least, we've started getting into analytics just like everybody else. Some of it we're doing to build sellable products to the market. Some we're doing to actually reduce our cycle time internally. So one of the things that we've developed is we've developed a product that goes through seismic samples and automatically picks out salt from the seismic. For those of y'all that don't know, salt is impenetrable by sound. So imaging around that and getting a good picture of what's around that is difficult. So we pay PhDs to sit there for 2 weeks or 3 weeks at a time and pick out salt from seismic lines by drawing little lines around them. I've worked at TGS long enough that I could go do the same job, never having been a geophysicist, and do it probably to 98% accuracy. So if we can get a machine to do it for us, so much the better. We actually did do that, and here you can see the time savings across the top. So everything that is in blue is human, everything that's in gray is computer. So the top flow, where you have the top of salt interpretation, the migration, base of salt interpretation, migration, and then the salt bottom interpretation, normally takes about 12 weeks, and you can see that a lot of human time in there and a lot of compute time in there. We've now dropped that down to less than 6 weeks, and mostly it's the time for the compute already saving. So why is this important? Because we're going to be using our storage in new and different ways than we have in the past. And our vendor has to be able to take those changes with us, right? So instead of a whole bunch of large files with thousands of nodes going up against them, we'll have millions and millions of really small files that'll be training in an iterative process through the ML. Oops. There we go. So in summary, why are we a Panasas customer? First and foremost, it's the partnership. They've been there when we've called. The support is great, and we get to talk to their support people and tell them what our particular issues are on a regular basis. I like the roadmap discussions. We have them with everybody while we're at Supercompute, but I can tell you most of those vendors, they do it while we're at Supercompute, and we get regular check-ins with Panasas. I'd say at least quarterly, just to make sure that we know what's coming up and where it's going. Performance. So far, like I said, 2 storage vendors have been able to meet the demands of our HPC, but Panasas makes it easy. And last but not least, looks like I cheated off of Steve's slides there, the TCO. We are very aware of what our TCO is. We know where the pain points are, and we get value out of the storage. And that's it.
Thanks, Jose.